All right, we got this diagram here with a bunch of missing pieces. So first thing we want to do is start with what we know. We know this piece down here, and we also know that this triangle is a 45, 45, 90. So um, in a 45, 45, 90, the side ratios are 1 to 1 to root 2. So in other words, right off the bat, I can solve for x. I know that x is the same measure because of these tick marks here. It's a right isosceles triangle, so x is root 3. There's one solution. And then the other thing is, if I take one of these legs and multiply it by root 2, then that will give me m. So in other words, m is equal to root 2 times one of the other legs. So we know the other leg is worth root 3, and radical properties allow me to combine those two into a root 6. So now I know m. So we're done with the 45, 45, 90 triangle. Next thing we've got to do is let's go after k. And the reason I'm going after k is because it's opposite the 30-degree angle. So if I take k and I multiply it in a 30, 60, 90, if I take that and I multiply it, my ratios are 1 to root 3 to 2. So if I take k and multiply it by root 3, that gives me what's opposite the 60-degree angle, or m. So one more time, take k, multiply it by root 3, that gives me m. Well, I know an expression for m, that's root 6. Okay, go through and solve for k. I divide by root 3, divide by root 3, and I'm going to take this one step farther. Uh, root 6, I'm actually going to break this up. We know that root 6 is root 2 times root 3. And we're dividing that by root 3. So simplifying, that we can actually get this thing to cancel. And that allows me to find that k is root 2. Last thing, if I want to find p here, this side p that's opposite the 90-degree angle, I got to take whatever's opposite the 30-degree angle and multiply it by 2, and that gets me to the 90-degree angle. So k happens to be opposite the 30, so if I take k, multiply it by 2, that gets me p. Plug in what we know it's root 2 times 2, and that's equal to p, and that's as far as we can go if we keep this in terms of simplified radicals.